Okay, 6.6 exponential and logarithmic equations. We're going to be solving them. So we need to remember that b to the x equals a. So log base b of a equals x. Yes? We can rewrite those things. So you will be writing things from logarithmic to exponential, from exponential to logarithmic, because we're going to be having to get at the a and the exponent. So in order to do that, you have to change forms. So if I have 1/2 to the x plus 7 equals 4 to the 3x. So x is in the exponent, yes? Okay. So when we have an equation like this, if we can get the bases to be the same, the exponents are the same, correct? Mm-hmm. So can we get 1/2 to and 4 to be the same base?
I mean, 4 over 2.
Say it, Dylan.
2.
2.
Yeah.
Isn't 4 2 squared?
Yeah.
And what's 1/2? 2 to the what?
-2.
-1, right? So I have 2 to the -1 to the x plus 7 equals 2 squared to the 3x. Now are my bases the same?
Why do you want your bases the same?
Because once my bases are the same, that means my what are the same? My exponents? Okay, so now I have -1 times x plus 7, because when I take a power to a power, I multiply, yes, equals 2 times 3x. What next? Distribute. So -x minus 7 equals 6x. Add an x.
Can we turn off the floodlights?
And then divide.
I'm seeing a glare.
We can't shut off the front, we can shut off side.
Well, can we shut off all the lights? Because I think there's enough light.
Are you guys good? Good enough light?
So
Yeah, this morning they didn't have enough light over there. So it's what?
-1.
So x is -1.
Is that all we're doing?
No, of course not.
See, you always say that.
Well, 'cause
You-
it's
oh,
so
you-
easy at first.
Okay, but you can't assume after one example. Have you already done problems like these?
No.
Yes. Yes, at the start of this chapter. 0.001 equals 10 to the 6x.
Okay then.
Can I make 0.001 10 to a power?
Oh my
To the third, fourth.
god. Fucking zero so bad.
Close on the third. Wouldn't it be the -3rd?
Why?
Yeah.
Because it's a decimal.
Okay.
Because the third would be 1,000. So I want 3 decimal places. So if I take 10 and I take it to the -3, that means I take this decimal place and move it 1, 2. Oh, actually, it's not 3. It's -4.
Told you.
So I take the decimal and go 1, 2, 3, 4. Okay. So equals 10 to the 6th. So now I have them in tens. What can I do?
Now you can do just work with the exponents.
No, why don't you move to the front?
No home today.
Okay, so -4 equals 6x.
Attention.
So divide by 6. No, you're not.
Yeah, we are.
So x equals what? -2/3. So we've done problems like that. We just need to remember. Okay? So let's go to the next kind. So when we did this, this property was, it was the 1-to-1 property, yes, because we had a to the x equaled a to the y, so therefore, so if, then x equaled y. That was that 1-to-1 property. So, and I'm gonna title it, so if you don't remember it, should you write it down? Okay, 1-to-1, and that's for exponential. So if I have a 1-to-1 property for exponential, do you think I have a 1-to-1 for logarithms?
Yeah.
Yeah. Okay, so what made this 1-to-1 work? What had to be the same?
The basis.
The bases. So what do you think has to be the same for logs? The bases. So log base a of x equals log base a of x equals log base a of y, then x equals y. And again, this is the 1-to-1 property, but of logarithms. So if we can do that, it will make our life easier.
What was that other one? The other 1-to-1?
Well, the other one was of exponents. This is of logarithms. Yes, ma'am.
Go office.
Yeah. Okay.
Oh no.
Okay, so then I have 3 to the x plus 1 equals 5 to the x. Okay. If I had this problem, the first thing I'd want to do is get the same bases, yes?
Yep.
Can I make 3 be 5?
No.
Nope. Can I make 5 be 3? No. But can we, and we saw this when we were doing the, compound interest formulas, and we had to solve for a variable that was in the exponent, and you guys didn't have the rule yet. Can I do anything I want to an equation as long as I do it to both sides?
Yeah.
Can I do that? Okay. So I'm going to do log of 3 to the x plus 1. Oops, I have this. Equals log of 5x. Now, did I do the same thing to both sides?
No. Yes.
Yes. What is the base now on both sides? 10.
Yep.
Okay?
So I just took it out of exponential middle one. Right?
Yes.
Basically.
Technically, yes. Okay, so now we're going to use our properties of logarithms.
Yes.
What happens with an exponent? What have we been working on the last 2 days? What happens with an exponent? What's your power property?
It goes in front.
It goes in front. So I have x plus 1 equals log of 3 equals
X.
x log of 5. Now what should we do?
Solve it.
Solve it? How?
Let me think.
If it wasn't log, if it was just 3, what would you have to do at this point over here? Distribute, wouldn't you?
Yeah.
So what should we distribute? The log of 3.
Yeah.
Okay? So log of 3 times x would be what? X log of 3. And then times 1, so plus log of 3 equals x log of 5. So now let's stop and see what we did. Okay, why did we take the log of both sides?
Because that's what we do.
Because we couldn't do what up here?
We couldn't get some of these.
We couldn't get the same base by in exponential form, so by putting it into logarithmic form, did I force it into base 10? Yes?
Yes.
Okay, so then I took my power property of logs and took my powers out front. And then I distributed, because that's what the math tells me to do, correct? So now, what am I solving for? What variable?
Right.
X, right? So we know from algebra, when I want to solve for x, all the x's have to be where?
On the same side.
On the same side, and everything else has to be on the
On this side.
other side. Okay? So what do you want to move?
The X's.
You can't move the x. You can't move just the x.
The whole thing.
What whole thing? You want x log of 5 or x log of 3? You have to get all the x's on one side. Guys, this is the same as saying 3x plus 3 equals 5x. What would you do?
X log 3.
You do
Move the
3x.
3 over.
How?
Subtract.
Subtract it. Okay, so this is the same as this.
Oh, okay. That makes.
Okay? So I'm going to subtract x log of 3. Now, is x log of 3 the same as x log of 5?
No.
No.
Could be a
So I can't combine them. So I have x log of 5 minus x log of 3.
Yeah.
So I have 2 x's and I only want 1.
Yep.
1. So you have 2 things that both have an x. You factor it out. Good job, Lily. So I have x log of 5 minus log of 3. And I think you already said, Carson, what we have to do next.
Yeah.
What's minus mean?
Oh.
Oh, fraction.
Divide.
Yeah.
Yeah.
So I have log of 5 minus log of 3 gives me log of... Oops. That's just 3 still, isn't it? So x log of 5/3. Okay. So what am I solving for? X. So what do I need to move?
Divide the 5.
I need to divide by the log of 5/3, don't I? So x is going to equal the log of 3 divided by the log of 5/3.
Yeah.
And then at that point, can I put it in a calculator?
Yeah.
Yes.
Oh, we did this.
And if I put that in a calculator, I'd have log of 3 divided by log of 5/3 is approximately 2.15. On the test, you're just going to have log of 3 divided by log of 5/3.
Alright.
Okay? But it may ask you, like in the textbook, to do to the nearest whatever. Okay?
Yeah.
So what did we do? Let's go back through it again, because I stopped you and I said, why did we do what we did? Okay,
Okay.
back at the beginning,
Yeah, the beginning.
we couldn't get same bases, so we had to do what on both sides?
Log.
Log. Could I have thrown in natural log? Could I have done natural log also?
I mean,
Yeah.
could.
Yes, I could have done natural log or log base 10. I could have done either one of those. Okay? So then, I did log,
Yep.
and then how'd I get from here to here? Power rule.
Yep.
So the exponents came out front. How'd I get from here to here?
You subtracted log.
Nope.
No, you.
Oh, the amount of
Distributed.
I distributed
Yeah.
because I need to get to that x so I can move them, right?
Yep.
And then how'd I get from here to here?
Subtract the
Subtract the
X.
Subtract the x because all the x's need to be on one side.
Yep.
Yep.
How'd I get from here to here?
I just
Factor.
factor the x.
Factor.
Factored out an x because I only want how many x's?
One.
One, and I can do it. How'd I get from here to here?
The quotient product
The quotient rule.
rule. Yeah.
So subtraction means division. So I condensed it.
Yep.
Now, could I have left it like this and just divided by the whole thing?
We guess.
Would that look weird?
Yeah.
Yeah.
Yeah. Okay, so I have x log of 5/3 equals log of 3. How'd I get from here to here? Divide. Are those basic algebra things that you do?
So,
The only thing you have what you're carrying it around?
yeah.
The log. Could you have used ln?
Yep.
Yes. I think we probably should do another one, do you?
No. Do you have a sticky note? Come on.
Hey, that's good.
I'm tired.
So when they change, you're going to flip out on me
What do you mean change?
when they're different.
Log.
Oh, natural?
Okay.
It's the same thing.
Natural log of x squared minus 16 equals the natural log of 6x. Okay, now we have the one-to-one property, yes? That says if the bases are the same, the ofs are the same, yes?
Yeah.
So are the bases the same?
Yep.
So that does that make this equal that? Yes. So we just get x squared minus 16 equals 6x. From here to here is the what? The 1-to-1? Okay, so now I have a quadratic. How do I know this is quadratic?
Square.
So we have to set it equal to,
0.
and then
Factor.
factor. So that'd be x squared minus 6x minus 16. To factor it. You get negative 8 plus 2. Okay, so x equals what? Negative 2 and 8. Okay, what does an exponential function look like? You guys remember? Doesn't it look like this?
Yeah.
So my domain is x such that x is greater than 0, yes? Okay, we may have a problem. One of these may not work, right? So, well, a negative 2. So if I plug negative 2 in here, I get 4 minus 16. Does that give me a negative number? Yeah. Can I take the natural log of a negative number? No. Also, if I put it in here, what would I get? A negative number. So does negative 2 work? No. So just cross it out. Now, negative numbers may work, but you have to check if they work. Okay? Now, 8. Is 8 going to work
Yeah.
in the first one? Yes. Is it going to work in the second one? Yes. Because it just can't be what? Negative. Don't assume the negatives don't work, though. Because if this was negative, if this was plus 16, would the negative work here? Yes. But it would fail over here. Just has to fail once. Okay? So if there's 3, do I have to check all 3? Okay. So, let's get you one on your own.
No, I'm good.
Log base 5
We got home.
of x squared minus 45 equals log base 5 of 4x. How'd you go? So -5 is an extraneous solution. Remember extraneous? Okay, everyone good? Regan, you good? Okay. Now, the last part of your assignment says using a graphing utility. So I'm going to show you how to use a graphing calculator. So if I were to graph this and this, the answer would be where the two graphs cross, correct? Yes? Isn't that the solution? Okay, so if I have log of 2x plus 1 to the 5th equals x minus 2. So I need to know this would look like this, yes, and x minus 2 would look like that. So it would be here and here. It could be like this and like this, so it would just be what? There. It could be like this and this, so it'd be what?
None.
No solution. Okay, so I can have one solution, I could have two solutions, I can have none. That's because this is linear, correct? Now, if this was quadratic, it would look like this, right? Quadratic is a parabola.
Yeah.
It could look like this and touch it once, or it could look like this and not at all. Okay, so what you're going to do is you're going to graph this and one and this and the other in your graphing calculator. So to graph, you go to y equals, because anything with graphing is right here. Anything with graphing is right here. So y equals, and we're going to treat this like one equation and this like another equation. So I'm going to put this in my calculator. So log of 2x plus 1 to the 5th and then we're going to treat this like an equation, x minus 2. So you're just going to put 1 and 1 and 1 and 2. And you're going to hit zoom. 6 is a standard screen because I think I messed with it. Okay, so there's 1 and there's 2. So they cross how many times? Well, one time on there.
On there. Looks like
I guess we may, let me see, zoom fit. It may, because like the one could go like this and it could clear out there, right? You can also go to zoom fit. It's still telling me there. If you think they cross, you can go to window. And so you're saying we need to see more X's, right? So we only go to 10. What do you want to go to, like 100?
Sure.
No.
I need to go Y 100.
Yeah, we need Y's.
So Y needs to go. Okay, so X didn't need to go 100. So see how I'm just going to window and messing with it?
Not yet.
So let's go to this 20 and Y to 100. This is Y max. And I don't need to see any of the 0. Like minimum could be 0, right? Probably minimum here could be 0 also. Is it going to cross again?
Is it? No.
Doesn't look like it, does it? We did enough exploring. We have a window from 20 to 100. I mean, and it didn't, we did 100, it didn't cross. I could go 100 to 100 if you want. But I still don't think it's going to cross.
No.
Because when I get that big, it looks basically straight, and it's only going to cross how many times? Once. So I'm going to go back to Zoom 6. Zoom 6 gives me a 10 by 10 screen. Okay? So I need to know where they cross right there. So anything I need to calculate with a graph, again, anything with a graph is here. See that button says calculate?
Zoom.
Okay? So second, calculate. And we want to know where they intersect. So which ones intersect? 5. So you hit 5. And up at the top, well, it says down here, it says first curve. And it shows you the equation. So you hit enter. And then look what it did. It automatically jumped to the second curve. And it says second curve. So you hit enter. And then it says guess. So you can move your cursor over. It doesn't have to be exact, just somewhere. So where do they cross?
2.
approximately x is
2.21.
2.21. Okay, so x would probably approximately 2.21. Make sense? Okay, we probably should do this together. Yes?
Sure.
Do what together?
It says it touches twice.
That's what I'm saying. It's coming back.
No, it's right here. It's showing it. Did I put it in wrong? Log of 2x plus 1 to the 5th. I'm going to put double parentheses maybe. Did that change that?
That's what I'm
Yes.
saying.
Okay, so what did I have to change when I did this?
Double parentheses.
I had to, because when it had that 5th on the outside, it was confusing it. Because I want of all of it, don't I? So now I'm going to go again. You guys remember how I got it?
Mm-hmm.
How did I get there? How did I get to it telling me?
It's the middle one.
Second
Second?
zoom.
Nope.
Window.
Calc. Calculate. Any number you want it to give you exact is going to be calculate, okay? And then what? 5 for intersect. Okay, it says first curve. Am I on? It doesn't matter which one's the first curve? Nope. So enter. Did it jump to the second one? Did it jump to the second one? Okay, so hit enter. Now you want to be to the intersection you want. So we're close to this intersection, so I'm just going to hit enter again. So I got 0.30. So 33, negative 2.33. Now I want this one. So what do you think I have to do again? The whole thing. Second calculate, 5, first curve, enter, second curve, enter. But if I want that intersection, don't you think my guess has to be close to that one? Yes. If you don't get it closest to this one, if I stop right here, it's going to give me which one again? This one. So you need to get it. It doesn't have to be exact, but it does. Does it have to be closer to the one than the other? Yes.
Wait, how do you? Are you pressing the right arrow?
I'm just these arrows. Okay, so now I'm at 8.20, 6.20. So I think we need to do one of these where you're touching the buttons. So everyone get your calculator. Don't you think we need to do one where you're touching your buttons?
Sure.
Yeah.
Carson grabbing one.
I think my form was constant.
That's why I hope we have one who's gonna wear stuff. Freaking Z-Box. What am I on?
Okay. So what are we gonna do first? Right here. What are we going to do first? What button on our calculator? Y equals. Okay, in the top equation, if it's blinking on your equal sign, just hit arrow over. We're going to put the left in one and the right in the other. So 3,
Window? No.
3.
parenthesis, 2 to the power, and then we're going to put parentheses. I'm going to clear that so you don't have to look at the other one. Okay, 3, parenthesis 2, stop,
Where's that?
to the parenthesis x. X is right here. It says x t theta n.
Oh.
X t theta n. Okay, x plus 2. End your parenthesis. Then you're going to, then get out of that. And then minus 1. Then the right hand side goes in y2. So 3 minus x. And then hit zoom 6 just in case anyone's messed with it. So how many times is that one going to cross? Just what? Once. So how do I figure out that point? What do I hit?
Calculate.
So second, calculate or trace, right? Then what?
Hey, we got the same.
5. And first curve, does it matter which one's the first curve?
No.
On all of them, they should say the equation right there. So hit enter. And then did it jump to the second one? Your instructions are at the bottom of the screen. The top of the screen is telling you where it's at. So hit enter. And then down here it says to do what? What's it telling?
Guess.
Guess. So my guess is it's just move your arrow so you know you can move it. And then hit enter.
Where do you go after you get the
That was not a very descriptive question.
You went too fast.
What'd you guys get?
I'm still here. 'Cause I couldn't
Second,
let go.
calculate.
Second.
What'd you guys get?
I got, you can't read mine? Well, now you can't, definitely. I got that. Did you get negative 1.21, comma 4.21? Okay.
Yeah.
So anytime I have a system of equations and have a calculator handy, could I just put them in the calculator and make it do the work for me? Yes. It's important in class for you guys to know how to do it by hand, but like for the ACT and things like that, can you make your calculator do it for you? Yeah. Okay. So make sure when it says calculator, you use the calculator to do it.
Yeah,
Okay.
I didn't do it right.
You didn't do it right?
What are you, a bum?